This week's practical, we're going to be looking at repeated measures designs now. We've been focusing mainly on independent ANOVAs. And what we'll do now is run through, first of all, a one-way repeated measures ANOVA, and then go on to a two-way repeated measures ANOVA for the second half of the practical. Now, when you're using repeated measures ANOVAs in SPSS, the output you get is quite similar to an independent design ANOVA. So a lot of the things that we're going through today should be familiar to you. The main things you need to focus on really is inputting the data correctly, both in the SPSS data file and also, especially for a two-way ANOVA, inputting it correctly when you're actually specifying the ANOVA in the drop-down menus. So if we run through the one-way repeated measures ANOVA first, what I've got again is a research design here, research scenario. So the sales department of a large company wanted to see whether giving incentives to employees would increase sales generated. In week 1, they were given no incentives. And then from weeks 2 to 4, the incentives increased then. So in week 2, they were given a £10 bonus for every £100 of sales generated. In week 3, this increased to £20 bonus. And in week 4, they received £30 bonus for every £100 generated. And they monitored the sales figures per employee each week, recorded what they'd sold at the end of the week. So we've got here repeated measures design. This time, each participant or employee is providing 4 data points. They're being measured at 4 time points, and they're providing 4 points of data. So for repeated measures ANOVAs, it's often used for this type of design where you've got multiple measures over different time points, but it's not limited just to designs which is reliant on time points. In the two-way ANOVA, we'll illustrate this point further. In this case, we've got one independent variable, which was the type of incentive, and measured across 4 conditions. So each week's incentive is one condition in this design. So week 1 would be no incentive, week 2, say, would be a small incentive, week 3 would be a medium incentive, and week 4 would be a large incentive. The dependent variable is sales generated. So this is now a one-way repeated measures ANOVA. And I've got this data now open in SPSS. Now, one of the things to note, first of all, is the structure of the data changes now compared to an independent ANOVA, because we've got no grouping variable now. We've got nothing to actually group these participants on because they're all taking part in the same conditions. So the first column was the amount of sales generated in week 1, second column, week 2, third for week 3, and fourth for week 4. So if you like, these now represent the conditions of the independent variable, but the data points themselves across all of these columns now represent the dependent variable. It's the score in terms of the amount of sales for each week. So what we'll do now is run one-way repeated measures ANOVA. So you need to go to Analyze, General Linear Model, and this time we're going down to the repeated measures option here. If you click on that, it will bring up this box. And you'll see now this is also slightly different to an independent design in that you need to define this factor, because otherwise we've got no way of labeling this independent variable. What do we actually mean by what we're looking at here? So what we'll do is change this within subject factor name just to something like incentive or week, you could change it to. And we've got 4 levels, because it's week 1, week 2, week 3, and week 4. So if you do that and click on Add, you can see this button then down here says Define. You can just press on that now, and it will bring up this box. And for a one-way ANOVA, this is straightforward. You just need to put each of these across into this box here. Week 1, move over to there. Week 2, week 3, and week 4. And these are now the within subjects variables by week. There are no between subjects factors in this model because we're not splitting anything by groups. So we can just select a few options that we'll need. So what we'll do is go to Options, and we'll click on Descriptive Statistics, Estimates of Effect Size, and we'll also move this week over to the Display Means box. Now, what we will want is to generate post hoc tests for these, because we'll have an overall main effect of the ANOVA, but because we've got 4 conditions, we'll need to pick that apart a bit further and see where the differences actually are. So what we do in this option is click on Compare Main Effects, and you can click on this box here. And these are the types of post hoc tests that we have available for a repeated measures ANOVA. You can see there's not very many available. There's just 3 that we can choose from. And the least significant difference, or LSD, this one here, is actually of limited use because it doesn't actually make any adjustments to the p-values in terms of the critical value, which is what a post hoc test should do. So what we'll do is you can choose either the Bonferroni or the SIDAC, and just follow the practical for which one of these to use. For this example, we'll use the SIDAC test. So what we can do is click on Continue, and then what we'll do is select Contrast as well, because I just want to illustrate something via this Contrasts option. So we'll just select that at the moment. And we'll change this contrast to a repeated contrast here. I'll click on that and then press change. And then that will just alter that contrast to a repeated contrast. Click on continue, and then we can run that ANOVA now. So click on OK. And what you'll see is for a repeated measures ANOVA, SPSS generates quite a lot of output for these. So I'll just focus on the tables that we really need to pick the information out of. The first table we'll look at is the descriptive statistics for each of the weekly sales. And you can see just from this table that it looks like sales are increasing across the weeks. So they start off at £427.93 for week 1, and then they gradually rise. So by week 4, they're £642.28. So from that, it looks like incentive is having an effect. The increase in incentives across the weeks seem to be generating higher sales. What we'll do now is go to this table, which is labeled Mulchley's test of sphericity. Now, this is very similar to the homogeneity of variances, the Levene's test that you did in independent ANOVA. This is slightly different in a repeated measures design, because what we're looking at here is not whether group variances are equal or unequal, but rather whether the equality of the variances of the differences between levels or conditions are similar. So you can imagine if you calculated the difference in the scores from week 1 to week 2, and then calculated the difference in the scores from week 2 to week 3, it's those differences that we want to be equal, rather than the actual scores on the week 1, 2, and 3. So in terms of interpretation, the main thing to note is it's interpreted the same way as the Levene's test. What you're looking for is a non-significant p-value. So here, for the Mulchley's test, we've got a p-value of 0.08. So that's not significant. It's approaching significance, but we can take that to mean that we've got equal variances between the differences across the conditions. If this is not significant, then things are pretty straightforward. We use this line here, which you can see in the second table. This is the statistics to use when sphericity is assumed. So when the Mulchley's test is not significant, then this is the line of data that you want to focus on. If the Mulchley's test was significant, what you need to do is use the corrected statistics, which are usually, most commonly, the Greenhouse-Geiser statistics, which are in this column here. And this, as with the corrected statistics from a one-way ANOVA, just applies a correction to the degrees of freedom, which can affect the p-value. So it's important to use the correct statistic if you've got a significant problem with sphericity. Right, so we'll just focus then on what this table, this within subjects effects table, is telling us. We can use the top line, as I said. So we'll pick out the degrees of freedom first. The degrees of freedom for this are 3 and 57. 57 are the error degrees of freedom. The F statistic then is 26.30. The p-value is less than 0.001. And the eta squared is 0.581, representing a large effect. Now, in this table, it's labeled here partial eta squared. Technically, this is an eta squared because we're looking at an overall model effect. So you can just, if you're writing this up, just indicate eta squared like this. And what we've got there is it's giving us the main effect of the ANOVA. So there's an overall effect going on. We know that there's some kind of change across the weeks. We can then use the post hoc tests, which in SPSS, this will be the pairwise comparisons table, to pick out exactly what differences we've got here. And I've put on the left-hand side the mean scores just to remind us of what's going on with these. Now, just remember for these post hoc tests, the way that the output is organized is that, first of all, you can compare week 1 with week 2 here. And to compare these two, you'd use this row of data. If you wanted to then compare weeks 1 with weeks 3, it's this row here. So you take the week 1, but go down to the second row, week 3. Use this row of data, and this is a comparison between week 1 versus week 3. So let's go through that now then. So week 1 versus week 2, can read across the line here, and the p-value is 0.059. So this hasn't reached statistical significance. In other words, this difference in mean scores from week 1 to week 2 here is not significant. If you wanted to compare then week 1 with weeks 3 and 4, you can have a look at these rows of data here, and this tells you that there are significant differences. So week 1 was significantly different to both weeks 3 and weeks 4. Or in other words, there was an increase in sales for weeks 3 and 4 compared to week 1. Now, what we'll do is go to this next block of data and look at this row. This is now the comparison between week 2 and week 3. So if you read across the line, you can see that the p-value again was not significant because it was 0.169. So the increase that we saw between weeks 2 and weeks 3 are not significant in this case. But if you wanted to compare week 2 with week 4, then this is significant. So week 4 generated higher mean sales than week 2. And then we've got one more comparison to make now. This is the comparison between week 3 and week 4. We can read across the line again, and this time the p-value is 0.045, so this is just significant, and we'll take that as a significant effect. Week 4 generated significantly higher sales than week 3. So what we've done with these post hoc tests then is compare every possible comparison that we can make amongst all the weeks. And if you remember, when you do these post hoc tests with something like the Bonferroni or SIDAC correction, it will adjust the critical value to account for multiple comparisons. Now here we've done quite a lot of comparisons, so the critical value will become quite low. And it means it's harder, especially if you've got a small sample size, becomes harder to detect significant effects. So there's another option in SPSS, which is the contrasts option. And I chose before the repeated contrast, and I'll just run through what this has done now. So this contrast is also comparing two groups at a time. This time it's being more selective about the comparisons it makes. In a repeated contrast, you can see what it's done is it's compared, I'll get the mouse sorted, it's compared level 1, which was week 1, with level 2, which was week 2, and then it's compared level 2 with level 3 or week 3, and then it's compared level 3 with level 4 or week 4. And it's just made 3 comparisons. And in this example, you could see that it would make sense to look at the data like this, because what we'd expect is over time, the increase in incentive would lead to an increase in sales. So we expect in the mean scores a gradual increase over time in sales generated. And what we really want to do is just compare the most meaningful comparisons. So in this case, we could see whether, first of all, did the sales increase from week 1 to week 2? And we can read across the line. And now this time, the p-value is significant at 0.01. We could then compare week 2 versus week 3. Did sales increase across this period? And again, if you read across the line here, this p-value is also significant. Then finally, week 3 versus week 4. Did sales increase across this period? Yes, they did also, and this was significant at 0.008. So you can see that using these contrasts has given us a very different interpretation to what we had from the post hoc test. This time the contrasts are indicating that there is a significant change in weekly sales week by week, which the post hoc test suggested wasn't the case. Now, what they suggest is that for the post hoc test, there may be a lack of power because you've done so many multiple comparisons. By limiting the amount of comparisons in the contrasts, we get around this problem. And this time, we get significant p-values suggesting a different relationship. Now, one point about these contrasts is that you should have a strong theoretical basis for using these contrasts. So in this case, we did. What you wouldn't want to do is run post hoc tests to see if anything's significant. If it's not, then run some contrasts to see if you can get anything significant out of that. You definitely want to avoid doing that. But if you've got a strong theoretical justification for just looking at certain comparisons in the data, then this is one where you can go about that. There's other type of contrasts available in SPSS as well. If you have a look in the Andy Field book, it will go through the types of contrasts that you can do. Right, just a note on writing up this repeater measures one-way ANOVA then. What you'd want to do is report the main effect of incentive. So there was a significant effect of incentive on sales generated. Report the test statistics. Make sure you report the mean scores to just give an indication of exactly what's going on in terms of the direction of the effect. And then in the second paragraph, I've gone on to the results from the post hoc tests, where you really only need to report the p-values for these. So week 1 sales were not significantly different to week 2 sales, but they were significantly different to week 3 sales and week 4 sales. Then week 2 sales were not significantly different to week 3 sales, but were significantly different to week 4 sales. Finally, week 3 sales were also significantly different to week 4 sales. And you can see that if you run multiple post hoc tests, the write-up can also become, as in this case, a little bit waffly. If you were using contrasts and writing this up, then you could write it up something like this. The first paragraph would be the same as before, but then for the repeated contrasts, we found that there was a significant week-on-week increase in sales from week 1 to week 2, from week 2 to week 3, and from week 3 to week 4. So the contrasts not only sometimes give you an increased power in terms of ability to detect significant effects, the interpretation is also simplified here, and it's getting to the point of exactly what we want to extract from this data. But as I said, you would only want to use contrast when you've got a strong theoretical basis or reason for doing so. If in doubt, use post hoc tests. What we'll do now then for the second part of the tutorial is go on to a two-way repeated measures ANOVA.